In this video, I'm going to walk you through all the different inference tests and how to determine which one the prompt is doing. All right, so the first question you're going to ask yourself is this question asking me about a proportion, percentage, or a mean? If it's asking you about a proportion, then this is going to be categorical data. Now remember, you can have numbers in categorical data, but they're going to be put into categories, and then of course your graphs would look like histograms and things like that. Versus if it's means, then you're going to have quantitative data. So if you have quantitative data, it's saying average, things like that. So be careful when you kind of go through here. All right, so then you're going to ask yourself if it's one population or two populations. Same thing here, one population or two populations. All right, so let's look at the categorical. And so for the categorical, the next question that you're going to ask yourself is you're going to look at and see, okay, if I have one population, we have, let's kind of put all of our tests down here. I'm just going to put, we have a one proportion z-test. We have a chi-squared goodness of fit test. So I would ask myself from here, from one population, and then we have, that's one population still. So then I have a chi-squared independence test. So you could ask yourself, you would say, okay, from here, do I have one variable or two variables? Well, if you have two variables, you know immediately it's going to be this chi-squared independence test. So I would say, okay, let's take this and say, all right, let's put that up there. Oh, somehow I erased that. Okay. All right. If it's, so then let's look at the determination. You would say at this point, how many categories do you have? You have one category, or you have, supposed to be a Y, or do you have more than one, two or more categories? All right, so if you have one category, you're talking about one thing, you know it's going to be a one proportion z-test. If it's two or more categories, you know it's going to be a chi-squared goodness of fit test. And let me just kind of do this, bring the line down so we can see that's what it's going to. Okay, so let's see, with two, so then let's keep going here with one variable, one population. So the other ones we have, of course, we have a chi-squared two-way test for homogeneity. We have a two proportion z-test. So let's see here. Those both have two populations. But from the two populations, let's go from here and do the same thing and say, okay, for the chi-squared homogeneity test, again, I'm going to see, am I comparing two populations? Do I have how many, am I comparing two things? So, or actually, you're going to see right away. I'm going to just say you have a matrix. Can you create a matrix or no matrix? That's honestly going to be really the easiest way. Because if you have a matrix, meaning you have data where if it's men women, and you have maybe red, green, blue. You've got a whole 50, 20, 10, 60, 35, 15, something. You've got a whole set of data, and obviously that's going to be with a homogeneity test. A 2-prop z-test is going to be, I'm going to bring it down here just because we're out of room in my chart. It's going to be more like if you have proportion 1 equals proportion 2. You're just going to have, you have 2 proportion where it would be p hat would be maybe red over men, and this p hat 2 would be red over women. I guess when I don't mean over, I guess I mean the proportion of red that men like red, the proportion of women that like women, or excuse me, women that like red. All right, for quantitative data, so for quantitative data now, remember, let's go ahead, I'm going to put these in a different color just so our chart won't go so crazy. We have a 1 sample T. We have a 2 sample, I'm going to write over here, T. We have paired T. And we have linear regression T. I think I got them all. All right, so for the 1 sample T, when I have 1 population, there's only one of them here that's going to be with a 1 sample T. All the others have 2 populations, but now we have to determine which way we're going to go. I'll go back to my pink just so we have my chart. So let's see, with this one, I want to know, are they independent or not? So if they're independent, I guess I could have written it like this. And then not independent. Immediately we know not independent is my paired. And this is independent. And so we possibly have a 2 sample T or linear regression. So let's look what we have is that we have from here, we're going to either have, this obviously has 1 variable versus 2 variables. 1 variable is 1 variable versus 2 variables. The linear regression obviously has 2 variables because when I graph it, I get a scatter plot. And that's 2 variables. And that's the linear regression test. And that's how we tell what type of test we have. So we have, remember we have intervals as well, but it's done the same way. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 possibilities there. All right, I hope that helps you understand how to determine if something, what type of test you have.